Okay, so this is the video for geometric proofs, which we do every section for the rest of the semester. So you may really want to watch this video 2 or 3 times until you get it down. Okay, it's the same process as algebra proofs, only we're solving a geometric problem instead of solving an algebraic problem. Okay, so some fill in the blanks. When writing a geometric proof, you use deductive reasoning. Remember, deductive is not where you figure it out by yourself, but you use laws and things people told you. So you use deductive reasoning to create a chain of logical steps that move from the hypothesis to the conclusion of the conjecture you are proving. By proving that the conclusion is true, you prove that the original conjecture is true. So we're going to have a sentence, and we're going to work through it step by step. We're going to start with the hypothesis, prove, until we get to the conclusion, and then we're done. Okay, so here's a little flow chart. We start with the hypothesis, and then all throughout the middle, we're going to use definitions, postulates, those properties like properties of equality and properties of congruence, and then in our theorems, in whatever combination we need to make it make sense, and then we will wind up with our conclusion when we're done. Okay, so that's our process. When writing a proof, it is important to justify each logical step with a reason, just like we did on our algebra proofs. If you added, you had to put addition property, and then you simplified, and then you divided. You had to tell everybody every step that you made. Okay, so this first example was supposed to have the left side filled out for you, and we're just going to practice justifying. So pause the video and fill out these 6 steps over here on the left so you're ready to prove. Okay, so we have a diagram on the side. I hope you copy the diagram as well. And it told us in the problem, given that A and B are complementary and A is congruent to C. So let's mark that in our diagram. A is congruent to C. Okay, so A and B are complementary. How do we know that? Well, we know that because they told us in the problem. So anytime they tell us, that is going to be a given statement. This first justify, which will always be the column on the right, is always going to start out with given. There's no choice but for it to start out with given because you can't make something up on your own. Okay, the measure of angle A plus the measure of angle B is equal to 90. Well, how do we know that 2 angles who are complementary add up to 90? We know that because that's the definition of complementary angles. Now, not always, but about 90% of the time, if you have a vocabulary word in this step, the next justification is going to be the definition of that vocabulary word. So that's a good pattern to look out for the rest of time. Okay, next, angle A is congruent to angle C. Well, how do we know that? They also told us that in the problem, so that is another given. Now, I prefer to put all my givens together, so I probably would have switched these 2 steps, and it would still be correct. It just is a matter of preference there. Okay, so if A and C are congruent, why does that mean that their measures are equal? Well, we talked about in Chapter 1 the definition of what congruency means. It means if 2 things are congruent, then they're equal, whether that be angles or lengths of sides of segments or anything like that. So this is also common where you have to switch from congruency to equals, and then you might have to switch back at the end of the problem. So you'll see this a lot. Anytime you see the same 2 angles or segments or anything, first time congruent, next time equal, the justification is definition of congruency. Okay, so then the 5th step is the measure of angle C plus the measure of angle B is 90. Okay, well, if you look back to step 2, we had A plus B is 90. Now then they told us, well, A and C are the same thing, so now we have C plus B is equal to 90. Well, what happened here is they substituted. So substitution property of equality. They swapped out A for C in this sentence. So instead of writing A plus B is 90, I wrote C plus B is 90 because A and C are the same thing. So I substituted C and A for each other. Well, then what does this mean? Well, if C plus B together equal 90, that means they're complementary. That is also the definition of complementary angles. Remember, we talked about in biconditionals in 2.4 that a good definition can work forward or backward. So that's what you're seeing right here. Complementary means they add up to 90. 90 means they add up to complementary. That's the definition, so it has to work forward and backward. Okay, rewind and rewatch that example if you didn't understand that. Okay, so vocabulary grid, the definition of a theorem said a statement that you can prove. So you have two kinds of things in geometry. You have postulates and theorems. A postulate is a sentence that's true because it has to be true. Somebody said it and it is true, so we just have to believe them. A theorem, on the other hand, you can actually prove that it's true using a proof. You can actually show the reasons why it would be true. Okay, so once you have proven a theorem, you can use it as a reason in later proofs. So this will come in handy because we'll prove theorems are true, and then later on they'll show up on the right side of our chart as reasons in later proofs. Okay. All right, also in your vocabulary chart, oh, sorry, I got lost. Okay, more fill in the blank. A geometric proof begins with a given and proof statements which restate the hypothesis and the conclusion. So we're really melding our proving that we did last section with our hypothesis and conclusion. So we're going to prove this statement is true. We're going to start with the hypothesis. We're going to end with the conclusion. So let's look at your vocabulary grid for linear pair theorem. And that says if two angles form a linear pair, then they are supplementary. And we already talked about in chapter 1 when we learned what linear pair was, that if they're going to form a line, then a line is 180 degrees, so the two angles have to be 180 degrees, and that means they're supplementary. Now we're just going to prove exactly why that is true. Okay. So what you have here is you have your given and your proof statement, which is the hypothesis and the conclusion. You could reread this as, if angle 1 and angle 2 form a linear pair, then angle 1 and angle 2 are supplementary. Now, the easiest part of proofs is these two steps. The given will always be the very first thing in your proof on the left side. And the prove will always be the very last thing. Because this is where we're starting and this is where we're going to end. This is what they give us to work with, and this is how we know we're done. So first and last, you can always fill that in. The other thing you can always fill in right away is the first reason will always be given. Okay, so good. We already have 3 out of our 12 boxes filled out and we didn't even do anything. Now, if you look down at the bottom of your notes, you have choices to choose from, and I'm just doing this while we get used to doing proofs. So you're just matching right now, and then as we move through, you'll be able to come up with these yourself. Okay, so the second step was already given to us. Ray BA and ray BC form a line, and that is definition of a linear pair. Remember, I told you if there's a vocabulary word here, usually the next reason is the definition of that. So that's holding true for now, so that's good for us. Okay, so step 3, we are talking about AB and BC forming a line. So we're worried about ABC down here. So let's look down at our choices. Angle 1 and angle 2, no. Angle 1 and angle 2, no. That's a justification. Measure of angle ABC is 180. If we're talking about opposite rays, that is this right here, the same thing. Measure of angle ABC. So I'm going to put that one next. Measure of angle ABC is equal 180 degrees. Okay. And how do we know that? So we've already used this one. Now we're looking for a justification. So this is a statement, this is a statement, this is a justification, justification, justification. So we only have 3 choices here. Do we know that because of supplementary angles? No. Do we know that because it's a straight angle? Yeah. Do we know that about angle addition? No, I'm not adding any angles. So I want definition of a straight angle here. ABC